Greetings and welcome. My name's Aaron Craig, and today we're going to be creating an awesome little game called Bounce or Break using the physics engine inside of GameMaker. You can see it right here. You're going to be able to shoot a ball at different objects, and it's going to be able to bounce around, and it's going to have a lot of life to the movement. It's going to feel very real because we're using a physics engine. It's going to be a total game so that you can play, you can keep track of your score, but when one of these objects gets up too high, the game resets and you can try again. If that sounds exciting, let's go ahead and dive in. You'll be able to follow along with GML or GML Visual. Make sure that you download the project because it's going to have all the sprites and sounds that you'll be needing to follow along with. Let's do a quick overview of this project. We're going to have the sprites for each of the objects, the arrow that we'll use, and the background. And we also have the sound that we'll be playing whenever this ball hits an object or a wall. And of course, we have the default room inside of here. So, to show you the basics of the physics world and engine inside of GameMaker, let's go ahead and get just a ball bouncing on a wall so that you can get familiar with it. So, let's go up to Objects, and I'm going to click on this plus icon, the Create Asset, and I'm going to click on Objects, and I'm going to tick it up to 2, because we actually want a ball and a wall. So I'm going to double click on object 1 and I'm going to rename this O ball. And then I'm going to scroll down and I'm going to rename object 2 to O wall. Now we've already got sprites for each of these. So I can just drag the SPR ball onto this object and I can do the same thing for the wall to SPR wall. So the physics engine that's built into GameMaker has to be manually ticked for every object and every room that you want to use it in, because it is not the default option when making a game. So every object is going to have this little box that says uses physics. We need to click on that, and then we have a little window that we can open up by clicking this physics button right here. And this is going to open up all the properties that we can control about this object. So things like density, restitution, the collision group that it's in, linear damping, angular damping, and friction, along with a couple of options here, and even modifying the collision shape itself. Now, there's a lot that we can go into, but essentially each one of these options is going to change how this object is interpreted in the world by how bouncy it is, by how heavy it is, and each one of these you can dig deeper into. For now, let's do a really quick overview so that you know why we're changing the numbers on some of these. The density of an object is how heavy it weighs, but this is distributed over the size of the shape of the object. What that means is this ball that's 32 by 32 pixels is going to be very dense if we give this a high number because it's a very small object. That same number would make a huge object actually be very light, maybe like a balloon. So the number, the strength, the amount of density that we have right here depends on the size of our object. And in this case, we're going to set the density of this ball to 75. That might seem like a big number, but don't worry, it's going to look and feel really great. Next is the restitution, and you can think of this number as how bouncy you want this object to be. The bigger the number, the bouncier it's going to be. In this case, we're going to set it to 0.75, and we'll set the other objects to make it bounce more when it hits them as well once we define their properties. Collision group just means that you can set every group of objects to a specific and unique ID. We don't need to worry about this at all for this project. Linear and angular damping are very similar. You can think of linear damping as the air in the world, all of those particles that as something is moving through it, it's actually hitting them and slowing down over time. Angular damping is that same thing except for rotating objects, so that when you want something to eventually stop rotating, that angular damping, it controls how quickly that will happen. And the very last one is friction, which is just how much something is going to slow down when it's hitting it and moving on it. So for linear damping, let's go ahead and change that to 0.25. And for friction, let's change it to 0.1. These bottom three, we don't need to worry about. The sensor, the starting awake, and kinematic, just leave it the way that it is. Lastly, let's look at the modify collision shape, because there are several different shapes that you can have available. And if we look at this one, we can actually see that this is the wrong size. So I'm going to zoom in by pressing the magnifying glass here. And you can see that this is actually a square, or a box in this case. And if we click on this drop-down menu, you've got three options: a circle, a box, and a convex shape. And I'm going to show you what each of these shapes does. For this one, let's go ahead and click on circle. And you can see immediately that it changes from a square into a circle, and it has a radius. And it picks the correct size based on the sprite that's there. So that's everything that we need to do to get our ball ready to actually fly and move around inside of the world. So I'm going to close the physics tab here. Then I'm going to scroll down. And for O wall, we need to do this same kind of thing, but it's going to be a little different, because this wall in our world and the point objects, we don't actually want to fall down as the game is being played. They need to stay in one spot. So there's a trick for that. I'm going to click on Uses Physics, open the Physics tab, and I'm going to set the density to 0. This makes it infinitely dense, which just means it is not going to move ever. Nothing can ever make this thing move when colliding with it. Now we have controls to move it, which we'll do, but if you want something to just stay there but still be able to be interacted with, setting the density to 0 is what you need to do. Now let's go through and alter the properties here. For restitution, let's put this to 0.75 so that when the ball hits it, it gives it some of its bounciness. And we'll change the friction to 0 because we don't want the ball to actually slow down at all when it hits this wall. And lastly, let's take a look at the collision shape. We saw before that it chooses box by default, and in this case, it's chosen box and set the size correctly, so we don't need to worry about it. Let's go ahead and close the physics windows completely and double click on room 1 to open it up. Now let's place the ball somewhere in the middle. Let's take that wall and let's click on it, click on a corner and drag it out to be a little bit larger. Now we'll be able to see the ball actually hit this and bounce on it. Before we do that though, we must set the room properties itself. So remember, every object must be ticked and set to use physics, and every room you want it in must also use the physics engine. So by clicking on the room, it will open up the inspector over here on the left. Click on room physics near the bottom, and you see that you can enable physics with the checkbox right here. Then you can control things like the gravity X and the gravity Y. In this case, we're going to set gravity Y to 125. So it's going to be pulling down with that much force. If you have things that are heavier or lighter in your room, this is going to treat them and pull them down in a different way for each object. In this case, our ball will be pulled down, but our wall, which is a 0 density, is going to stay exactly where it is. So let's go ahead and we're going to change the target from GX Games to test, and I'm going to press play. And we'll be able to see the physics engine working immediately right here. And there we go. The very first test of the physics engine in GameMaker. And you can start to see that with no code and just setting a couple of numbers, you can actually get a game up and going. Now, we want to actually turn this into a game that we can play. So let's go ahead and start adding some objects and some code into them to be able to control them. So let's jump back over to our workspace, click on objects, and then I'm going to click on the plus icon, and I'm going to click objects, and I'm going to type the number 6 because we need 6 more objects here for the rest of the project. Let's go ahead and make them right now. Click on create, And now we have all of them that we need right here, and we'll rename them and add them to the right spot as we move along. So first, let's click on Object 3. This one we're going to call O Controller. This object is going to be the arrow that actually moves around and then spawns the ball and shoots it out when we click on it. So that's pretty useful. Next, let's right click on Objects, and I'm going to click on Create Group here, because I want to keep this project organized as we make it and as you might want to expand it as you get finished with it and want to try out some new things. So I'm going to click Create Group, and I'm going to call this Group Points. And then I'm going to click on Object 4, hold Shift, and click on Object 8 to select all of them at once. A lot faster this way. And then drag them into this group. This is where all of the point objects are going to live, so let's put them in here. Now, for O Controller, before we jump into the points, let's go ahead and assign that arrow to it. And this one does not need to use physics, so we don't need to check this at all. Now let's go over to Object 4, and this one I'm going to call O Circle, and I'm going to drag the SPR circle onto it. This one is going to need physics, so let's go ahead and click that. Open physics. And these properties are going to be the same for all of the point objects that we put in here. So we just need to change density to 0 and restitution to 0.5. And we have to make sure that the collision shapes are correct. So let's click on this. And you can see this is a box, which is no good. So let's click circle, and we're all set. I'll go ahead and close this out. Object 5, I'll double click on, and this one is going to be called O Diamond. And then we'll drag the SPR diamond onto it. And for this one, we need to click Uses Physics, change the physics to 0, and the restitution to 0.5. And for this one, let's go to the collision shape. Now, a diamond is just a box turned, but GameMaker doesn't know that, and this box is not, it doesn't have any way to turn like this. So instead of a box or a circle, we're actually going to click on Convex Shape. Take a look at this graphic here, and you'll see the difference between a convex and a concave shape, which you'll be tempted to create as you start making physics games. A convex shape for GameMaker can have up to 8 points, and all of those points have to be going outward. In a concave shape, some of those points bend in, kind of like a Pac-Man, and GameMaker does not natively support a concave shape. In another part to this series, I'll show you how you can use concave shapes in GameMaker without too much hassle. So we are going to actually add these points manually. I'm going to go ahead and zoom in, and I'm going to click on the top of the diamond, and you just get it kind of lined up, and it'll be perfectly fine. I'm going to click over here, and that should be good. Then I'm going to click down here, and you'll see that it makes a triangle. Now we need to add one more point to this end, and there we go. That is our convex diamond shape that we want to use right there. And we're all set. So I'm going to go ahead and close that and click on our next object, Object 6. Let's go ahead and name this one O Square. And we're going to drag the square shape onto it. Click Uses Physics. Click on the Physics tab. We're going to change the density to 0, restitution to 0.5, and it uses box by default, so the square is all set. Let's close that. Last point that we're going to have is going to be the triangle. So we'll call this O Triangle. Drag this onto here. It uses physics, and we have to set the density to 0 and the restitution to 0.5. We need to modify this collision because a triangle is not a box or a circle. So we're going to click on Convex Shape, zoom in, and we can start these points anywhere that we want, but we're going to click right here, here, and here, and it makes that triangle for us. So that's the really nice thing about making these custom shapes. It really is pretty simple. Let's go ahead and close this out. And that's all the points that we're going to need. The last object that we're going to use, we'll go ahead and name it right now, is going to be called point parent. And we're going to talk about parents and inheritance because we want to have multiple point objects inside of this game, but we don't want to have to repeat our code over and over. So we're going to put nearly all of our code inside of this one point parent object, and we'll give that code to all of its children, and it'll be really quick and easy. So first up, let's go ahead and get the ability to aim and shoot and create a ball up and running. So let's click on O controller, and we're going to add a step event. To follow along in GML, look to your left. To follow along in GML visual, look to your right. In the step event, we're going to set our image angle to the value of what we get back from the function point direction. So we pass in where we're at, where our mouse is, and then we can set our image angle correctly. Okay, now that we've got the image angle set properly, let's go ahead and add another event. This one is going to be the draw GUI or GUI event. For this event, we're going to draw the score, but anytime we draw, we also want to make sure we set the color properly. So we're going to set it to white, and then we'll draw the score of the player with a caption of score right before that. And next up, we're going to use the global left pressed event to spawn the ball and shoot it out where it's supposed to go. So let's go to add event. It's going to be under mouse, all the way at the bottom, global, and global left pressed. There's a lot going on here, so let's break it down line by line. The first thing we're doing is checking that no other ball exists. And if that's true, we're then going to create a new ball object right at the arrow. We're going to save that in a temporary variable called ball. Then we're going to get the point direction, so where we want this ball to actually be flying towards with the function point direction. Then we're going to create a couple of local variables called x force and y force. And these two variables we're going to multiply against a special function called lengthdir, both for x and for y. And this is going to give us the length and direction of how much force we're actually going to shoot this ball out with. And the last thing we do then is finally apply that force to the ball. And we use a special physics function, because we're inside of a physics world here, called physics apply impulse. This function immediately applies that force that we set up with our variables x force and y force and puts it onto our ball and is going to send it flying exactly where we want it to go. For the GML visual users, be sure that you use that little arrow and you check that this function, physics apply impulse, doesn't apply to self, but actually applies to the ball object. Okay, that's everything we need to do to be able to shoot the ball and test this out. So let's jump back over to room 1. And because the code requires there isn't a ball, let's go ahead and delete this one. And to set our room up right so that we can actually see it and it looks a little bit cooler, let's go ahead and go to background. And I'm going to click on no sprite, go into the sprites folder, and I'm going to choose the background. And this is going to be the size of the game that we're creating. So let's go ahead and quickly change a few more options here. Let's click on room 1 so that we can see the properties over here in the inspector. And we're going to change the width of the room to 480 pixels. And we're going to change the height to 720. So this is going to be the size of the room that we have. This is a pretty common, or actually the most common, resolution for phones, and that's kind of what we're making this game for. So let's go down to viewports and cameras, and we need to enable viewports. Go to viewport 0, click visible, and now we're going to change the properties to those same ones we set the room to. So the camera is going to be 480, by 720. The viewport properties are going to be 480 by 720. And once we've done that, our camera and our room are all set up the way we need them to be. So let's go back and click on Instances, and let's drag our wall in here, and let's drag our arrow and put it right here for now. And let's click F5 to run our game. And now our arrow, we can actually click, and there's our ball, and it moves, and it bounces just the way we want. To make this a little cooler, to be able to actually shoot multiple balls at once, we need this ball to be destroyed when it leaves the room. But first, let's get this arrow lined up. So let's click on the arrow, and if you try to move it, you'll notice that it snaps to the grid. Well, if you hold the Control key, you can undo that snapping for the object you're moving, and let's drag the arrow so that it's right here. The base of it is right there at the tippy top, and that is going to make it look and feel much, much better. Then let's click on O Ball, and let's add a new event. And this event will trigger when the ball is outside of the room and destroy it. As simple as that. It's under the Other Events, the very first one, outside of room. For this, all we need to do is destroy the instance with the function instance destroy. And now we can test this out. Let's run our game one more time, and if we shoot the ball, we can shoot it as soon as it leaves. And now you can see we can kind of shoot the ball wherever we want on this, and it will bounce wonderfully. Okay, now that we've got that working, let's go ahead and tackle the points and getting them moving up the screen as we play. And this is going to be simpler than it seems because we're going to use that parent object we created. So let's jump over to point parent. And a parent is a way for us to share code among objects and be able to use other functions inside of GameMaker to be able to find all of those children whenever we want to. We're going to use this functionality, and it's going to save us so much time and energy. And this system is great for anything like multiple groups of enemies or multiple objects in your game that can be interacted with or anything along those lines. So this will save you time down the road if you learn it and master it now. In our point parent, let's go ahead and start with the create event. Let's add it here. So we're going to set points equal to 2 plus our score divided by 10 so that it changes over the course of the game. And finally, so that it's a nice round number, we're going to use the function round on the variable points. Next, let's add the step event. Add event, step. For this event, we're going to always be asking the question, has the player lost by one of the point objects getting too high in the level? So we're going to check if the Y of any point object is less than 90, which is just above the border of our game. And if it is, we're going to show the message game over. We're going to reset the score to 0, and we're going to restart the game with the function game restart. Next, let's go ahead and add a draw event. This one's not draw GUI, it's just the draw. And anytime we add the draw event, we also have to add the draw self, otherwise the object doesn't even draw its own sprite. So we'll add the draw self event first so we don't forget it. Then we're going to take care of coloring and setting the text for when we actually draw it at the end. So we're going to set the color to black, the horizontal or H alignment to center, the vertical or V align to middle, and finally we're going to draw the text from this object at its X and Y, and we're going to draw points, the text value. And lastly, what we're going to do is add a collision event with the ball. So let's go to add event, and it's going to be collision objects with the ball object. In the collision, we're going to subtract 1 from points because there's been a hit. Then we're going to play the sound effect bounce, and we're going to play it at only a quarter of its initial volume because the sound effect is a little loud. Then we're going to check to see if there are any points left. So if points is less than or equal to 0, which means that it has no points, we're going to destroy this object. And we're going to increase the score by 1. Now, we don't ever add the parent object itself into the room, but we do have to set each of these children to be children of the parent. So there's 2 ways to do this. The first one is in the parent object itself, we can click on parent, and we can click on this plus to add a child, and we can navigate to wherever one of these is. So in this case, if I click on O circle, that is now a child of this one. The other thing you can do is click on the object itself, go into parent, and up at the top, instead of under children, under parent, you can choose the parent. Now, watch what happens when we do this. There are 0 events in this diamond object, but as soon as we navigate into our group and select the point parent object, voila, all of those events automatically get added inside of here. They're grayed out, and they have this little icon here to indicate that it's coming from the parent. Now, it's possible to override it, but for this game, we don't need to do that. This is going to take care of the logic for all of our point objects, and it's awesome. So we just need to select square and triangle, go to parent, and we can drag the parent here as well to assign it. So let's do that there. Go to triangle, click on parent, and drag that parent there as well. And now if we return to the point parent object, we can see all 4 of these point objects, these shapes, are children. So if you don't have that, make sure you add them here. You can drag them here to add a child if you didn't do that already. And once we've got this set up, our game is almost complete. So let's go into our room, and let's go ahead and take this wall, and I'm going to go ahead and delete it for now. And let's just put a few of these objects inside of our game. Now, we don't have the logic to having them move up, but everything else is set in place. So let's go ahead and run our game, and we'll see that when we shoot, they're actually going to go down in health. Now, that ball went up and out and it died, so let's shoot again. And voila, we can shoot and it can bounce and it can hit these, and that is the primary logic and the mechanics of our game taken care of. Now, this ball bouncing out of the room and dying instantly, that's frustrating. So let's take our wall object. I'm just going to click on it here, and then I'm going to basically paint it as an outline for our level. So starting in the top left, I'm just going to hold Control, and then I'm just going to drag all the way down to right around there. And this will make it that every single time the ball hits one of these, it just bounces right back. Now, one of the things you can do is you could add one wall object and drag this here, but this can do something kind of funky to physics-based games when we want to start doing a special kind of collision. So I'm going to nix that, and I'm just going to paint each individual wall square onto here. There we go. Then we want to do the same up here. So I'm going to paint at the very top. And once we've done that, I can center fit our room. And now our game is this close to being done. So we can click on this, and now the ball bounces throughout the whole room, and it looks and plays perfectly. The last thing we need to do is actually have these point objects move up every single time the ball dies. And to do that, we're going to use the event we already have. So let's jump back to our ball object. And inside of here, where we destroy it, let's add in that logic to actually move up all of the point objects. And we can do that because we have the inheritance with a parent already set up to make it really simple. So because of the point parent, we only have to apply this code to that one object, and it will apply to all of its children. So the one line of code we need to apply is subtracting 100 from its physics position y. And the very last thing to do is to just spawn more blocks as they move up. So when we move them up, we'll also spawn more. So to do that, we're going to actually take the code that we've got already, and in between destroying the ball and moving them all up, we are also going to create a new one. So we're going to use the choose function and action block here to choose from all of the different objects that we have available for the points objects. We're going to save that in a variable called new points, and then we will use that variable along with the variable we're going to create called point x to choose where along the x-axis to create this object. And then we can call instance create with new points and point x. So every time that this happens, it will create a new object randomly chosen along a new point randomly chosen, so it feels dynamic and random every single time we play. And that's it. Let's go ahead and run our game, and you'll see that we can shoot, we can destroy objects. When the ball goes down, it makes a new one, they all float up, and we have a beautiful, fun physics game. So that's it. I hope you enjoyed this project, and be sure to check out ways to even extend this further and take your physics knowledge in GameMaker to the next level. Leave a comment, share what you enjoyed, and what you're going to do with this project to make it even better. I'd love to hear about it. But as I like to say, keep making, keep learning, and I'll talk to you later.